Well, thanks so much for showing interest in this course. It's called Information Theory as a Basis for Machine Learning, using the game Mastermind as an example. Now, Mastermind, if you don't have it, go and buy it or get some pen and paper and play with pen and paper. But it's a kid's game. Or is it? Mastermind is actually the subject of a number of scientific mathematical papers dedicated to the concept of how many trials do you need before you can get a solution. Now, this isn't a comprehensive esoteric discussion about the game Mastermind. I provide a solution based on what I call machine learning. And I think it is fair to call it machine learning. I'm just going to walk you through an example of what the outcome of this course is. And you can decide if you want to do it or not. Now, even though this is a highly mathematical course, I don't think there's any mathematics whatsoever. I do, however, explain concepts. So in the game Mastermind, we start and we try 1, 2, 3, 4. Now, if I want to cheat, I can look at the code, but I'm not doing that at this stage. I score it, and it says that there's none in the exact position, but one is in the scenario, but not in the exact position. Now, in my previous course on information theory, I explained how we can calculate the probability that certain digits lie in certain positions. So we calculate the probability. And here, that's the form. We're using Excel solver. It's converged, we say OK. And it updates the probabilities. Now, this is where the machine learning comes in. We use these probabilities to do our next move. And it scores it. And we calculate probability, we do move, and so forth. And eventually it converges to a solution. And your objective from a game viewpoint is to see whether you can beat the machine learning algorithm. I'm not going to go through the whole example, it's in the course. But that's an example of what I'm doing. So fundamentally, I'm explaining what is happening in this move. Now, there's courses I've constructed already: Practical Introduction to Information Theory and Geometric Introduction to Markov Chain Monte Carlo. This tends to be mathematical. This, I've reduced the mathematics as much as I can. So I would say that these are prerequisites. There's really not much point, despite the simplicity of what I'm presenting, there is a chance you will get lost if you don't do these courses. But if you choose to do it without the prerequisites, that's your choice. Now, there's 2 other courses which are helpful, but they're easy to pick up. So mass balancing using Excel solver. I would suggest that if you're not familiar with Excel solver, you would want to do this course. And the other one is effective use of name ranges. Again, if you're not familiar with name ranges, do this course, although the concepts are easy to pick up. So the concepts taught in this course, and it's about a 2-hour course: information theory as a basis for machine learning, how to automate Excel solver using VBA, the application of Markov chain Monte Carlo, particularly the Metropolis-Hastings algorithm, and an introduction to simulated annealing. In all courses, I'm really avoiding formal mathematics, particularly in this course. If you're an engineer or a scientist, you could really go through this course with the child and explain it to them. The concepts really aren't that complicated, and that would give them a huge advantage when they do high school mathematics. So who is this course immediately targeted toward? Well, machine learning experts, particularly those unfamiliar with information theory. And I have to say, there are many machine learning experts not familiar with information theory. Most people who study probability at university, advanced high school students wanting to understand advanced mathematical concepts via simple explanations, Excel developers who are of a mathematical background, wanting to gain insights into automating and applying Excel Solver. So these people wouldn't necessarily want the whole course, but they want certain lectures in it. And as I said, under adult supervision, children who play Mastermind. So where is this course leading in the future? Surprisingly, mineral processing. The concepts I teach here will later be used in really advanced engineering courses, and my domain is mineral processing. The course structure is contained here, and there's 6 sections: the introduction, a background to machine learning applied to Mastermind without actually solving it, how to automate Excel Solver, then the particular type of Markov chain Monte Carlo technique is the Metropolis-Hastings algorithm, which works hand in hand with simulated annealing. So this lecture here is the final explanation of the methodology. We, of course, conclude, and then I discuss other applications, which I'm hoping you will see that just from studying Mastermind, there's a whole host of real engineering science problems which the methods can be applied to. So I really hope you join in this course. I'm looking forward to your participation, and it will be a lot of fun.